Right, so here we're going to look at another example of volume and surface area. So here we see this is a bolt which has a hexagonal head this on this side and a cylindrical body right here. So as you can see, the hexagonal head is in the form of a prism with a regular hexagon as its base, with its side length being 1 and the height of the prism being 1/2. And for the cylindrical body, it is just a cylinder with a diameter or base diameter of 1 and a height of 4. So we need to find the volume and surface area of the boat in terms of pi. And also further note that this question requires the Pythagorean theorem, so just keep that in mind. Notice that since this boat is actually a composite figure, we can just calculate the volume as the volume of the hexagonal head itself plus the volume of the cylindrical body. So notice that the hexagonal head is in the form of a prism, so its area will be the base area times its height. However, we're not really given the base area right here, so we need to do a little bit more work. Alright, so let's just take a look on our hexagon right here. Notice that we can divide this hexagon into 6 congruent equilateral triangles right here. So it then reduces 4 to calculating the area of the hexagon. We can just calculate 6 times the area of one little triangle right here. So I've drawn a little replica of one of these triangles. So notice that each of these has a length of 1. And for the area, we can just draw a little perpendicular line right here, which bisects this little line segment right here. So this little length right here has a length of 1/2, and this is just 1. And by the Pythagorean theorem, one can check that the length of this little red line is square root of 3 over 2. So the area of the hexagon will be 6 times 1/2 times its base, which is just 1, times its height, which we've just discovered, at the square root of 3 over 2. This will leave us with our area of 3 over 2 times square root of 3. Let's get back to our original problem. So the volume of our hexagonal prism will be just its base area times the height. So it will be just 3 over 2 times square root of 3 times 1/2, which is our height right here, plus the area of the cylinder, which will be pi times its radius, which will be 1/2, not 1 because 1 is the diameter, times its length or its height, which will be just 4. Simplifying, you'll get an answer of 3 over 4 times square root of 3 plus pi. For the surface area, notice that we can just move the circle right here, which is from the cylinder, and then stick it into the hexagonal prism so that it fits in to form the surface area of the whole hexagonal prism itself. So that the surface area of our boat right here will be just the surface area of the hexagonal prism plus the curved surface area right here. So notice that I've shaded in the surface area of the hexagonal prism in green and the curved surface area of the cylinder in blue. So let's use our two formulas right here that we're going to use. So the surface area of a prism is just 2 times its base area plus the perimeter of its base times the height of the prism. And the curved surface area of a cylinder is just 2 times pi times r times h, or pi times d times h, where r is the radius of the base, d is the diameter of the base, and h is the height. For the surface area of the prism, it will be just 2 times its base area, which will be 3/2 times square root of 3, plus the perimeter, which will be 6, since we're adding 1s 6 times for the number of sides in the hexagon, times its height, which will be just 1/2, plus the surface area of the curved surface area of the cylinder, I should say. That will be just pi times its diameter, which is just 1, times the height of the prism, which is just 4, leaving us with a final answer of 3 times square root of 3 plus 3 plus 4 pi, which ends this video.